So let's start with some basic mathematics that is helpful for our NEET preparation. So starting with, we got quadratic equation. Generally any equation which is in the form of ax square plus bx plus c is equals to 0, that is a quadratic equation. The roots of quadratic equation are given as follows: x is equals to minus b plus or minus square root of b square minus 4ac upon square root. And then what else we got? We got some trigonometry, which is quite helpful for our NEET. Some trigonometric identities. First is, as usual, first of all let's understand what is sin theta, cos theta, tan theta. If I got a right angle triangle, let's say this is A, B, C. Now sin theta is equals to opposite side by adjacent side. Opposite side is AB, by adjacent side is AC. And what about cos theta? Cos theta is adjacent side by hypotenuse, that is BC by AC. And what about tan theta? Tan theta is opposite side by adjacent side, which is AB by BC. And we need to remember that another theorem called Pythagoras theorem. I guess we all are familiar with that. And Pythagoras theorem says that AB square plus BC square is equals to AC square. Now this is A, this is C, this is B. Or A square plus C square is equals to B square from this triangle. And we got some trigonometric identities that we better remember. First, quite important, sin square theta plus cos square theta is equals to 1, and secant square theta minus tan square theta is equals to 1. Cosecant square theta minus cot square theta is equals to 1. Trust me, you won't be using these two formulas anytime soon in your NEET preparation, but this guy is quite famous and quite important. Sin square theta plus cos square theta is equals to 1. And we all know that a very famous Pythagoras triplet, which you all better remember. This is 53. That doesn't look like 53, so let's convert it to 37. That is 53. Now the opposite length, that is 3, 4, 5. I hope you all remember this Pythagoras triangle. Now sin 37 is, you better remember that, opposite side by adjacent side, which is 3 by 5. And what about cos 37? Cos 37 is that is 4 by 5, and so on. And what else trigonometric identities we got? We got sin A plus B is equals to sin A cos B plus cos A sin B. But more than this, you will be using this sin 2A, sin 2 theta is equals to 2 sin A cos A. You would find this identity most helpful because this keep popping up in our projectile motion, in our ray optics also you will find this equation. Or generally you can even write it as sin theta is equals to 2 sin theta by 2 into cos theta by 2, half angle formula. And also you will be finding cos A plus B. Cos A plus B is equals to cos A cos B minus sin A sin B. And what about cos 2A? Cos 2A is equals to cos square A minus sin square A. Now if I substitute that cos square theta minus cos square theta plus sin square theta is equals to 1. So cos square A minus sin square A can be written as cos square A minus what can I write? 1 minus cos square A. That would be 2 cos square A minus 1 is equals to cos 2A. Or I can write quite an important equation, 1 plus cos theta, which is equals to 2 cos square theta by 2. This is also quite an important equation because this you will find it by finding the resultant of two vectors of same magnitude. Let's say you got two vectors f and f. Now resultant is square root of f square plus 2f square cos theta. Now if I take that, that is 2f square plus 2f square cos theta. Now that is f square into 2f square common exponent, that should be 1 plus cos theta. That is f comes out to 2 into 1 plus cos theta. But what is 1 plus cos theta? 1 plus cos theta is 2 cos square theta by 2. So that is f into square root of 2 into 2 cos square theta by 2. That's how you are getting f 2f cos theta by 2. So that formula is quite important. So 1 plus cos theta is equals to 2 cos square theta by 2. Or even you can substitute cos square theta is equals to 1 minus sin square theta, then you get another result. So that is also another thing that we better make a note. And that's all from the trick. trigonometry. You got sin 2 theta, 2 sin theta, cos theta, quite important, and 1 plus cos theta is 2 cos square theta by 2. That you will even find it in wave optics. Resultant intensity IR is equals to 4 I naught cos square theta by 2. And then we got some geometry that we all better remember. First thing is, if you got a square, if this is length L, now this length would be root 2L, and half of that would be root 2L by 2. And if you got a triangle, an equilateral triangle especially, now the distance from centroid to any vertices, that is a by root 3, and this distance would be a by 2 root 3. And what else we got? That's all for geometry that we might be using most of the times. And remaining is we got differentiation, quite an important thing which most of the people struggle with this. One is d by dx of x power n is equals to n into x power n minus 1. Quite important. For example, what is d by dx of some constant that is equals to 0? Let's say d by dx of 5 is equals to 0, and d by dx of x square. In place of n you got 2, so you can write it as 2 into x power 2 minus 1, which is 2x, and d by dx of x is equals to 1. Don't write dx cancel and you got 1. That's not how it works. Just that d by dx of x power 1, which is 1 into x power 1 minus 1, which is 1 into x power 0. X power 0 is 1. And whatever d by dx of ln x, that is 1 by x, and d by dx of e power x is equals to e power x, which you don't find it any time soon in your NEET preparation, but definitely d by dx of sin ax plus b is going to be a cos ax plus b. This you will find frequently. Let's say d by dt of sin omega t plus 5, that is equal to omega into cos omega t plus 5. So you will find this equation quite often. So sin d by dx of sin ax plus b is a cos ax plus b, and whatever d by dx of cos ax plus b, that is minus a sin ax plus b. So these are the important things from your differentiation. And if you ever find this d by dx of root x can be written as d by dx of x power 1 by 2, that is 1 by 2 into x power 1 by 2 minus 1, which is 1 by 2 x power minus 1 by 2, or 1 by 2 root x. So d by dx of root x is 1 by 2 root x, another important formula that we better remember. So anything, use this formula. D by dx of x power n is equals to n into x power n minus 1 is quite an important formula. And coming to integration, integration. In integration, you got integral x power n dx is equal to x power n plus 1 by n plus 1. Let's say integral x cube dx, that is x power 3 plus 1 by 3 plus 1, which is x power 4 by 4. What about x power root x dx? Root x can be written as x power 1 by 2 dx, that is x power 1 by 2 plus 1 by 1 by 2 plus 1. Now, what about integral 1 by x dx? Now you might be thinking it as x power minus 1 dx, integral x power minus 1 dx, which is x power minus 1 plus 1 by minus 1 plus 1, which is x power 0 by 0. But something by 0 is undefined in mathematics. You can't divide something by 0. That is correct, right? So integral 1 by x dx is ln x. Why? Because integration is nothing but antidote of differentiation. Let's say you are differentiating d by dx of x square is equals to 2x. Now bring this guy, integrate 2x, then you will be getting x square. So integration is nothing but reverse process of differentiation. So that's why d by dx of ln x is equals to 1 by x. So that means if I integrate 1 by x, I should be getting ln x. So that is the idea behind this. And what else we got? We got some integration of constant. What about integration of constant? Integration of constant is equals to x. Constant dx is equals to x. And we got integration of sin ax plus b dx, that is minus 1 by a cos ax plus b. And integral cos ax plus b dx is equals to 1 by a sin ax plus b. And another important thing, integral e power x dx is equals to e power x, because e power x, whatever you either differentiate or integrate, you'll get the same. So that's another beautiful function in our integration. And we got some dynamics of differentiation. d by uv dash is equals to u dash v plus v dash. That's quite an important rule. That is what I call it as product rule. For example, PV, if you got PV, d by dt of PV is given by p dv by dt plus v dp by dt. That's what you keep saying in your thermodynamics most of the times. And this is what I call it as product rule. And we got a division rule. U by v dash is equals to u dash v minus v dash u by v square. That is rule for division. So let's say if you are doing d by dx of sin x by x. Now v is x and u is sin x. So first to write u dash, sin x differentiation is cos x into x minus v dash is 1, u is sin x by v square is x square. So that is how you differentiate. U instead of u I got sin x here, instead of v I got x here. Now substituting that, you would be getting x. So this is what I call it as product rule. This is a division rule. Even you can derive this from this, but let's not worry about it forever since we don't have much time. So that's it for today. See you all in the next video.